Welcome back. We've done a brief run through of the JavaScript runtime and asynchronous JavaScript. Now, this is something that we're going to get into a little bit deeper later on in the course, but I hope by now you should have a good understanding of the difference between a JavaScript engine and a JavaScript runtime. The way that I like to think about it is like this. You see, a JavaScript file is kind of like musical notes, ways for us to write music, write programs. The JavaScript engine is kind of like the musician or the composer. That person is the one that can read this music and understand it and make sense of it. And then the runtime is kind of like the whole package where we have the musician, but we also give that musician, besides the musical notes, all these tools to play our beautiful music. So let me ask you this. If we're able to have different JavaScript runtimes because, well, JavaScript can run outside of the browser, what do you think Node.js is? Well, is Node.js a programming language? Is Node.js a JavaScript engine? Is it a runtime? Well, this kind of gives it away. It's a JavaScript runtime. It's not a language. It's a runtime. You see, up until 2009, you ran JavaScript code inside of the browser. That's why people didn't really respect JavaScript. They thought it was a silly toy language. Well, Ryan Dahl in 2009 decided it would be great to run it outside the browser. Because up until now, we only had that runtime, that web API and the callback queue and the event loop, all browser-based. So he created Node.js, which is actually a C++ program. You can actually think of it as node.exe. It's an executable, right? A C++ program that provides this runtime for us. And if we look at the Node.js runtime, you see that it looks quite similar with our browser-based runtime, doesn't it? When it comes to Node.js, there are a few differences, but it works the same way as our diagram. We have our V8 engine, and then we have our event loop and what they call our callback queue. And they use something called libuv, which again is written in C++, for us to do these asynchronous operations with the V8 engine. Now, when it comes to Node.js, it does a little bit more than our web browser runtime. You see, in the case of a browser, we're limited to what we can do in the background, right? The browser isn't going to allow us to do much on the person's computer. You can't really access, for example, the file system of the user. I mean, that would be a huge security flaw. It just runs on the browser on the tab that we're currently on, in what we call a sandboxed environment. But in Node, we can pretty much do most of the things in the background. We can access file systems. We can do all sorts of things. You see, Node.js uses the Google V8 engine to understand the JavaScript, but it uses this libuv library, which works along to create this event loop to extend what we can do in the background. Now, here's the fun thing. If I install Node.js on my computer, and let's just run Node, if I type in window here, well, I get an error. There's no window like we had in the browser. Instead, Node has something called global, and that's its global API. You see that just like we had with window, in Node we have this global API that we can use, which also happens to have set timeout, set interval. That's nice, but also has some extra things that we couldn't do in a browser. And that is why Node is set to be a server-side platform based on asynchronous I/O that is non-blocking. It means that it uses JavaScript, but outside of the browser, but it creates this entire environment, this runtime that runs outside of the browser, and it allows us to have the same model of a single threaded model, but any asynchronous tasks can be non-blocking. That is, they can be passed on to what we call worker threads in the background to do the work for us and then get sent back through the callback queue and event loop onto the stack. We were able in 2009 to have a different model to perhaps create servers. You see, back in the day, we would create a thread for each request. Something like PHP would work like this. And if what we call the thread pool, that is, however much the server can work, is maxed out, well, the requests would just have to wait for the other ones to be available again. Node.js changed this mentality and said, hey, we only have this one single thread. But as soon as you give me a thread, I'm just going to pass it off to my asynchronous runtime to take care of it. And this simplified things a lot. Now, there's pros and cons to each method, but I hope now you see the power of the runtime, how it adds on this extra feature to JavaScript so that we can finally have the capabilities we had in the browser, but also the capabilities outside of the browser. I'll see you in the next video. Bye-bye.